Welcome to my new calculus channel. My name is John Gabriel. In this video, I'd like to talk a little bit more about the epsilon-delta definition in Weierstrass's formulation, so-called rigorous formulation of the limit definition. So if you look at this particular definition here, you'll see that it states very clearly that the distance between x and c must be greater than 0. Now, that's a requirement, because if it's not greater than 0, then this definition will fall apart. Let's see how this works. So if we go to our little GeoGebra material, we'll see that this function x, which is given by x cubed minus 2x squared plus 8x minus 5, is shown here in the diagram. So that's g of x, right? And we can move this point all along here. Now obviously it's never defined as f of x, because f of x is this function. Okay, f of x is the function that's multiplied by x minus x over x minus x, right? In other words, it's defined, it's nowhere continuous. Okay, so it's nowhere continuous and everywhere differentiable. That's contradiction in terms, isn't it? Okay, so mainstream academics must have a hold there in order for this definition here to hold. Otherwise it doesn't hold, and there is no rigor in calculus. Isn't that correct? Okay, so the truth is, trying to introduce a hold at this particular point in the curve happens through some very dumb arithmetic. For example, x minus the x coordinate of this green point tells us that it can't be defined anywhere on the green point. So the value, the question mark that you see here, means the function isn't defined. This h, this particular function here, h. So if we do that, let's get rid of this. Okay, so h is not defined at the green point. Okay, so at this green point here, you'll see there's a question mark. H is not defined. Now, if we multiply f of x, g of x by x minus x over x of x, then you'll see that the function is nowhere continuous, but everywhere differentiable. Okay. And coming back to this particular screen here, it's impossible, it's literally impossible for this to be true under any circumstances. Why? Because if this part here is true, then the function is defined at c. It's impossible that the function is not defined at c. In fact, what you see in the blue box was the original definition of Weierstrass with respect to continuity at the point c. Okay, so the morons in mainstream academia had to add this particular stipulation here, and they had to introduce a hold. So to cover up their stupidity, ignorance, and gross incompetence, this is exactly what they did. They multiplied by x minus c, as you see over here. Okay, this is x minus c. Of course, we just move this back up here again, x minus c, right? Okay, so what's happening here is that you can, using their dumb approach, you can actually introduce holds everywhere in a particular function, simply by multiplying by x minus x over x minus x. But that just doesn't make any sense whatsoever, because a function is a mapping, and one doesn't just get to say that by definition the function isn't the function isn't defined at a certain point. It has to be defined at every point if this particular condition holds here. In other words, if the distance is less than delta implies this, then it has to be defined. And the only way you can cover the stupidity of mainstream morons, for example, if you have a curve like that, and you're trying to find the tangent gradient there, you can't, for example, just keep on taking a secant line closer, which approximates this line here. And the reason is that this finite difference here is never represented at that point. Okay, so the calculus was never made rigorous. In fact, before my new calculus, the rigorous calculus did not exist. So I encourage you to look into these facts, to look into this particular scenario here. You've got all the equations on the side here. You can easily download the algebra from the web, and you can see how that h of x is really the product of g of x and f of x, right? And that's how you make the holy f of x function, which you can't see. It's now an invisible function, as you can see there. But it does exist, it's just invisible because it's not defined anywhere, right? In other words, it's nowhere continuous and everywhere differentiable. Isn't that a paradox? Doesn't differentiability imply continuity in the standard calculus? Of course it does. So everything fails. I hope you have enjoyed this particular presentation of the series on academic ignorance and stupidity, and invite you to join me again in a future episode where I'll reveal more ignorance and stupidity. If you like my videos, become a subscriber, click on like, and that will encourage me to make more videos and to reveal more ignorance and stupidity. So the choice is yours. And also visit my new calculus channel and learn the first and only rigorous formulation in history. My name is John Gabriel, and this is the new calculus channel. Until next time, goodbye.